welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held in the month of March 2025. It is a rescheduled examination for Assam Center. In this video, we discuss the solution of a problem from the section Algebra and from the subsection Ring Theory. In this problem, we discuss the ring homomorphism of a given situation. This problem is placed in part B, which is a multiple choice question. It carries 3 marks. The question ID is 706519. Further, this question is suitable for all these examinations. Right. The given question is, consider the ring homomorphism psi from C bracket x comma y, a polynomial ring in 2 variables with coefficients coming from C. It's a polynomial ring. To C of t. It's a polynomial ring in 1 variable with the coefficients coming from C. Psi is a homomorphism defined by psi of the polynomial f of x comma y in 2 variables will be mapped to f of t square comma t cube, a polynomial in 1 variable t from C of t. Right. Which of the following statements is true? We are given 4 options. Option 1, psi is surjective. Option 2, if p1 of x y plus p2 of x belongs to ker psi for polynomials p1 of x, p2 of x belongs to C bracket x, polynomial ring C of x, then both the polynomials p1 and p2 are the 0 polynomials. Option 3, there exists non-zero polynomials p1x, p2x belongs to C, the polynomial ring in 1 variable C bracket x, such that psi of p1 of x multiplied by y plus p2 of x is equal to 0. Option 4, there exists a f belongs to C x comma y such that psi of f of x comma y is 0, then and psi of f square x comma y not equal to 0, both such that both of them happen. Right. Not equal to 0 in this case. Psi of f square of x comma y not equal to 0. Right. Let's now discuss the solution of the problem in detail. We are given a ring homomorphism psi from C of x comma y to C of t defined by psi of the polynomial in 2 variables f of x comma y is equal to f of t square comma t cube. Agreed. Let's take the option 1. Psi is surjective. Is psi surjective? That's the question. Right. We consider image of psi. And if image of psi is not equal to the codomain C of t, then it is not surjective. So the image of psi is the set of all psi of f of x comma y, all the images f of x comma y belongs to c of x comma y. That is, the set of all polynomials f of t square comma t cube belongs to c of t. Such polynomials will be there in the image of psi. Agreed. Now, the powers of t in image of psi. What will be powers of t? T square, t cube. The powers of t will be ab plus 2b. The powers are non-negative integers, linear combinations of 2 and 3. That's what I said, 2a plus 3b. Since we are talking about t, what about t? Is t in C of t? What is the power of t? 1. Since the integer 1 cannot be expressed in this form, that is at square plus bt cube for any ab, the polynomial t belongs to c of t is not in image of psi, because 1 cannot be written as a linear combination of 2 and 3. So, t power 1 is not there in c of t. So, the polynomial t belongs to c of t is not in the image of psi. Right. T will be in c of t, but t is not in image of psi. So, that means image of psi is not the whole of the codomain c of t. Therefore, psi is not a surjective mapping. Right. This is what the proof that what I can think of. But you can think of a suitable, situation, counter example. Rather, this itself is a counter example, and argue also. Anyway, option 1 is not true. Right. We move to the next slide. Option 2. If P1 of x multiplied by y plus P2 of x belongs to kernel of psi, for the polynomials P1 of x, comma P2 of x belongs to C bracket x, then both the polynomials P1 and P2 are the zero polynomials. Now, P1 of x multiplied by y plus P2 of x belongs to kernel of psi means the psi of this polynomial must be 0. So, f of, this is psi, this is not f, this is psi. Psi of P1 of xy plus P2 of x is equal to 0. It is our habit to write, homomorphism as f. No, it is psi. Yes, psi. Belongs to ker psi means psi of this is 0. So, what will be the image? Replace x by t square, y by t cube. So, P1 of t square, t cube multiplied by plus P2 t square is equal to 0 for all t. Let P1 of x be a non-zero polynomial. Then P1 of t square is non-zero. Then P1 of t square multiplied by t cube is also non-zero. It is non-zero. Plus P2 of t square is 0. Is it possible? But this cannot cancel with P2 of t square. Why? Because the degree patterns are different. What is the degree pattern? For P1 of t square t cube has degree divisible by 2 plus 3. Whereas P2 of t square has degree divisible only by 2. Since the degree patterns are different, this can happen only when these polynomials must be 0. They cannot cancel unless both of them are 0 polynomials. So, option 2 is true. We move on to option 3. There exists non-zero polynomials p1 of x comma p2 of x belongs to C of x, C bracket x polynomial ring, such that psi of p1 of x y plus p2 of x is equal to 0. Right. If you see carefully the statement of option 3, it is the negation of the statement of option 2. Option 2 is true. The negation of a true statement will be false. Therefore, this is a false statement. The negation of the statement of option 2 is there exists non-zero polynomials p1 of x, p2 of x belongs to C of x such that p1 of x, y plus p2 of x belongs to kernel of psi. Reverse, you are right. You see, that's the negation. p1 of x, y, p1 of x multiplied by y plus p2 of x belongs to kernel of psi means the image of this under psi is 0. That is psi of p1x y plus p2 of x is equal to 0. This is precisely this one. Right. So that's what we get. So the statement of the option 3 is the negation of the statement of option 2. Since the option 2 is true, option 3 must be false. Since the option 2 is true, option 3 is not true. Okay, we move to the next slide. Option 4. There exists f belongs to C of xy such that psi of f of x comma y is 0 and psi of f square of x comma y not equal to 0. Can it happen? Can it happen? So what it says is there exists a f belongs to C of x comma y for which psi of x comma y is 0. That means f of x comma y is in the kernel. Kernel is an ideal. Therefore, its square is also there in the kernel. That means psi of f square must be 0. But here it is given not equal to 0. This is not true. Anyway, there exists f belongs to C of x comma y such that psi of f of x comma y is 0. Now, psi of f square of x comma y is equal to psi of f of x comma y multiplied by f of x comma y. What is psi? Psi is a homomorphism. Psi respects multiplication. Therefore, psi of f of x comma y multiplied by psi of f of x comma y because psi is a homomorphism. But psi of f of x comma y is 0. So this is 0 into 0 is 0. It cannot happen this. It cannot happen for any. That means this, in this statement there exists a f for which this happens and this happens. There cannot be any such thing. If there is a f belongs to xy such that psi of f of xy, then psi of f square xy ought to be 0. It must be 0. This cannot happen. Therefore, option 4 is not true. Right. Summarizing all the options, the answer to this question is option 2. That is the detailed discussion of the solution of the problem from the section Algebra, which is based on the concepts of ring homomorphism. In this case, the polynomial ring in two variables with the coefficients coming from C is taken, and normally such a ring we do not consider in our discussions many of this, but here it has come and we have studied in our MSc classes. It has come and a situation is given and you have to understand the situation and answer the question. I'll also tell you It's very rare, very rare of getting a question that you have done in a classroom that appears in the examination, in this type of examination. Maybe in our MSc it can happen, but in this NTA examination it cannot happen. Therefore, you must have a very open mind, and you must apply all the theorems, results related to that, and get the answers. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure we'll be meeting once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.